In today's video, we will introduce data operator and what it can be used for. After this introduction, you will know the tool and will have a broad overview over its features. We will answer the following questions. What is data operator? How to use data operator? And how to continue your data operator journey after this short introduction. So what is data operator? In short, data operator is a utility that enables you to edit large sets of measurement files. While measurement files are the very foundation for all automotive calibration, analysis, and modeling efforts, it is surprisingly hard to work with these files in everyday life. Let's have a look at some easy tasks that one may face when working with measurement files. We will assume that you would have to do one of the following tasks for 100 files you recorded on your last campaign. How would you tackle such a task for 100 files currently? How much time would it take you to tackle the task? Renaming a signal in these files because it has been misconfigured. Adding a calculated signal to directly analyze a relationship between signals. Splitting the measurement files into chunks of more manageable file size. Reducing the files only to areas of interest. Combining measurement files of multiple recording devices to have one file with all the signals at once. Aligning such measurement files of different recording devices such that they don't have any time offsets. Converting the measurement files into a different file format. Compressing the measurement files such that they are easier to upload or download. What do you think? How long would that take you currently? Data operator allows you to do all these things and many more through a simple-to-use tool. It can make your life easier and enable new and potentially automated workflows. This allows you to spend your time efficiently and on the interesting things you want to spend your time with. Let's have a look at the tool in practice. When creating a job, you configure a workflow consisting of source files to process, a sequence of operations to apply, and a destination to which the processed files should be written. In this short video, we will show two exemplary workflows. In the top right, you can see the input files folder. In the bottom right, the output folder to which we will write the files. Let's select the files for the compression demo. These files are in a legacy uncompressed MF4 format. We want to use data operator to compress these files to make them more manageable. Data operator automatically loads the signals from the files and checks their validity. Sometimes files can be corrupted when recording. Often this leads to tools not being able to process these files correctly, such that the files cannot be used. In this example, example2.mf4 has such an issue. Data operator allows to repair such files in an automated manner using a best effort strategy. Let's use it to repair our broken file while compressing. In this case, we just need to select MDF 4.11 as a target format since this uses compression. We select an output folder and tell data operator to add a suffix of underscore compressed to the new files. With this, we are ready to run the workflow. Let's have a look at the initial size of the files to see the comparison while the files are repaired and compressed. We select the files and inspect their properties. Oh, the job has already completed. Let's have a look at the results. Data operator shows us the resulting files and allows us to open their location. We already have that opened in the bottom right Explorer. Comparing the file sizes, we see how drastically the file size has decreased. What used to be 800 megabytes is now only 120 megabytes. That's an impressive decrease by 85%. Let's check whether the issues with example 2.mf4 have been resolved as well. As we see, all errors have been resolved and we are ready to use the file. Data operator can do so much more than just repairing and converting measurement files. Let's have a look at our second demo to show another set of features. Within this demo, we first want to add a calculated signal vehicle acceleration derived from the measured vehicle speed signal. This could be used for selecting relevant areas of the measurement files or within further tools down the analysis pipeline. We add a calculated signal operation and enter the name for the calculated signal and the formula for calculating the gradient. Data operator comes with a Python API that you can use. As seen here, you can use powerful libraries such as NumPy for your calculations. As a second step, we want to show the slice by condition feature to only extract relevant areas. For sake of simplicity, we will select all areas in which the vehicle speed has been larger than 30 kilometers per hour. Now we only have to select the destination folder and start the job. Data Operator is now processing our two measurement files and looking for areas of interest. Note that Data Operator also comes with a headless CLI that allows you to automatically run workflows from the command line. The job is completed. Let's look at the results. There are now multiple subfiles for the two original measurement files. You can now easily see how often the condition has been met within the files. Let's have a detailed look in MDA inspecting the results of GPS demodrive.maf4. We select the individual files and add them to MDA. Let's first look at the slicing. We plot the vehicle speed of the measurement extracts in an oscilloscope visualization. To do so, we first select the vehicle speed signals and drag them into the main window. We see the individual extracts plotted in the oscilloscope. The y-axis starts at 30, which shows that only the relevant areas have been extracted. Note that the timestamps of the original measurement file are still available in the sub-measurement files. This allows to easily find the areas of interest in the original measurement file. If you want the excerpts to be squashed together, you could use the combine operation of Data Operator. Let's look for the newly calculated vehicle acceleration signal. This signal has not been part of the original measurement. We have added it using Data Operator. By adding such calculated signals to the measurement file, they can be used in any tool supporting measurement files without the need to specify them in each tool again. You can see that the acceleration is positive in areas of increasing vehicle velocity and negative in areas of decreasing vehicle velocity. Data Operator is a toolbox of valuable operations to perform on measurement files. There are many more operations than the ones that we have shown in these two small demos. They enable you to perform any operation you may need to perform on measurement files. There is even a Python API that allows you to create your own operations in a plugin system. See the Python scripting guide shipped within Data Operator for further details. Additional topics worth mentioning. Data Operator also ships with a CLI that allows for automated execution of workflows. On top, you can store workflows as files, share and load them to easily reuse them within your team. Last but not least, you can reach our support team by contacting us through the contacts listed in the tool or through the ETAS website. Additionally, our field application engineers at ETAS are happy to support you in your first and the following more advanced steps with our tools. Thank you for your interest in our tool. We hope that Data Operator can support you in your daily work life and will empower you in your journey towards tomorrow's automotive software.